Okay, so we start with this chapter 8.4, okay? Introduction and the 17 identities that we're going to do before starting exercise 8.4. This is the test 8.4A portion. You can note it down, okay? So first question we'll start with the introduction is the trigonometric identities, okay? First we're going to prove the some primary identities geometrically, okay? Prove geometrically. Means we have to use a right triangle, a geometric figure, which is the right triangle here. Let us start to prove the A here. Sine square A plus cos square A equal to 1, okay? Is equal to 1. Okay, so we're going to prove this one is equal to 1 geometrically, given that value of the angles will be 0 degree less than or equal to A less than or equal to 90 degree. This is the condition. So for that, on a plan surface like a flat piece of paper, let us say there is a fixed line. It means that line is not moving. AX, because the angle here is A, so we put here A. There is another line together with it coinciding, which is a revolving line, let us say AP, and it moved up to here, revolved like the hand of a clock and reached here, making this angle XAP equal to A. Okay, and this A angle value should be greater than or equal to 0. 0 degree should be equal or less than A. That means A can be equal to 0 or less than, okay, can be equal to 0 or more than 0. And A is less than, can be less than or equal to 90 degrees. So that is the condition. So let us write down, let a revolving line, let us say revolving line, as we have taken here, AP, starting from position AX, starting from AX, or you can just specify a little bit more if you want, from position, starting from position AX, trace means make, okay, trace out this angle XAP, angle XAP equal to A, such that this condition is maintained, 0 degree less than or equal to A, less than or equal to 90 degree. Okay, in the end we'll discuss the detail of what is this. Okay, for now you just write like that. Okay, so here, then after that, from this point P you drop a line, let us say PM, whatever you want, you can put actually perpendicular to AX. So we write here, draw PM perpendicular to AX. So we get here now, therefore in right triangle AMP or APM or PAM, whatever, AMP, PAM, in this triangle, okay, with respect to theta, with respect to A, angle A. So here we have taken XAP equal to A, so with respect to A, the two arms of this angle A, what are the two arms? AM and AP, that's right. So which one is not the arm of A angle in the triangle? Yes, that's right, PM. So that is called the opposite side. Okay, opposite side. So here, opposite side is simply PM. Then, what are the two arms of this 90 degree here? Say, yes, that's right, MP and MA, right? Which one is not the arm of the 90 degree in the right triangle? That's right, AP, and that is always called the hypotenuse. And then finally, the one not marked here is called the adjacent side. So let us write there, the hypotenuse is AP, and then the adjacent side is AM. So we know and identify the three sides having name: opposite, hypotenuse, adjacent of this right triangle. Now we can take the identity that you're going to prove. Let us take out the left hand side. Okay, the left hand side is what? Read it. That's right, cos square A plus sine square A. That's the left hand side of the equal sign. One is on the right hand side, this one is on the left hand side. So geometrically, the question is saying proof geometrically. So that means we have to use the sides of a geometric figure here, right triangle. So what is, in our first chapter in trigonometry, we learn the ratio cos A is what? That's right, adjacent by hypotenuse. That's correct. Now here, which one is the adjacent? Yes, that's right, AM. So divided by hypotenuse. That's right, AP. So AP. So here square means we can just put square everywhere because the square will belong to everything. AM square by AP square plus, then sine A in our first chapter, the ratio sine A is what? Opposite by hypotenuse. That's right. So which one is the opposite here? That's right, PM. See here, PM. So we write PM square because this is sine square A by hypotenuse is AP. That's right. So we write here AP square because this square belongs to both. Now we see here the denominator is same here. So the LCM of just like 2 and 2 is LCM is 2. Likewise AP square LCM is AP square. And AP square into 1 is AP square, right? And 1 multiply AM square, then we'll get here simply AM square plus, similarly 1 into PM square, right? Then we write here. Now we remember the Pythagoras theorem. What does Pythagoras theorem say? Okay, which is the hypotenuse in this right triangle? That's right, AP. So Pythagoras theorem says the square on the hypotenuse, AP square, is equal to the sum of the other two sides. There are three sides in the right triangle. And Pythagoras theorem is only for right triangle. That's right. So here AP square equal to the other two is PM and AM. So PM square plus AM square. Or you can also write AM square plus PM square, right? It's the same, right? So here AP square equal to AM square plus PM square by Pythagoras theorem. So this one here, see, exactly this one is equal to here. We can replace by AP square by down here AP square, and we write here behind here, since we know AM square plus PM square is equal to what? AM square plus PM square equal to AP square, right? So in the first proving, we are doing detail and slow, so we understand. Once we get it, we'll move faster from the next one, okay? So that is the reason why AM square plus PM square has been replaced by AP square. So this one will cancel, and everything cancel means 1 is left. So we did not use any other method by using the sides of this right triangle AMP. So that is called geometric method, okay? So here is equal to, now right hand side, left hand side is, we took it and we got it equal to 1. Right hand side also 1, so we can just put here. We have just shown by geometric method that left hand side is equal to right hand side. So that is complete, right? So it proved this identity. Now let us go to the next identity we want to prove, B. Write it down. Okay, B is 1 plus tan square theta equal to sec square theta. 1 plus tan square theta is equal to sec square theta, okay? So we're going to prove this. This time it's not A, theta is the angle. So what we can do, we can use the same one if you want. Let a revolving line AP starting from position AX trace out same angle XAP, okay? But in the question, the condition is given as, we shouldn't forget that, 0 degree less than equal to theta, okay, should be less than, okay, less than, clearly not less than equal to, but less than. There's a difference in condition here. So let a revolving line AP starting from this one, instead of A, this time it will become theta. Or you can use OX also, up to you, but I'm just using same one. Then this condition is changed, so this is now A in place of A theta, and instead of less than or equal to, it is only less than. As you can see, the condition given in the question. And draw PM perpendicular to AX, that's fine. So with respect to you can write here theta now, because XAP is now XAP is going to be taken as theta. So opposite will be same. The two arms of theta are AM and AP. So opposite. Hypotenuse is same. Adjacent same. You can write it down up to here. Okay. Now you can pause the video and write up to there. Then now let us take the left hand side, just like we did geometric method now. Clearly equal is here, so left hand is this side, which is 1 plus 10 square theta, right? Then here 1 plus 10 theta is what? Yes, that's right. Opposite by adjacent. That's right. So opposite is PM, as you can see in the diagram also, by adjacent is AM. So you can put square in both because this is 10 square theta, right? So now by simplification method, we know this can multiply to 1. So AM square into 1 is AM square plus that one will remain same. Because you have multiplied up to here, the long line will now cover the whole thing. Divided by LCM is AM square. So AM square plus PM square again, which is equal to then AM square plus PM square. AM square plus PM square is AP square. So we write here again AM square by Pythagoras theorem plus PM square, the two non-hypotenuse sides, when you square them and add, that is equal to the hypotenuse square by Pythagoras theorem. So AP square by AM square again, because we know AM square plus PM square, this one equal to AP square. We know that by AM square plus PM square equal to AP square by Pythagoras theorem. By Pythagoras theorem. I think in the first proving we forgot to write by Pythagoras. You have to write that, okay? In the solving of A, also you write by Pythagoras theorem. That is important. Now that is there. Now what is AP? Here AP is hypotenuse. And what is AM? Is adjacent. Hypotenuse by adjacent. What is the name of this ratio? Hypotenuse by adjacent. In the first chapter? Yes, that is correct. Sec. But this is square, so we put here square, sec square, and the angle is theta. So AP square by AM square equals to sec square A. We know this from our first chapter, right? From the first exercise, sec square theta, which is exactly the same as this right hand side. So you can just write here equal to right hand side. As I said, don't forget to write by Pythagoras theorem. Even in the first, before B we did A, there were, I think we forgot to put it there, okay? So now we have again proved geometrically, okay? Now the third one has two sections, I think. So let us do that. These are important. It comes in exam sometimes, okay? So C, we have to prove 1 plus cosec square alpha. Suppose it comes like that, cosec square alpha is equal to cot square alpha. 1 plus cot square alpha is equal to cosec square alpha. Okay, condition is different again, 0 degree, less than alpha, less than or equal to 90 degree. This is the condition given in the question. So we can keep on using the same figure if you want, okay? Draw the same way. Or you can change it to O, OP, OX, also up to you. Now here everything will change. Everything will be same except this will change, alpha. And this condition will change according to this question condition. Less than theta instead of theta alpha. Less than or equal to this time. So make the adjustment up to here. Draw PM perpendicular to AX also will be same. Then one more slight adjustment we have to make is here, alpha, okay? Do that, okay? Pause the video and write down. So compared to alpha now, we have to change this theta, remove it, and change it to alpha. Okay, C, this is C, subheading 1. Don't forget that 1. Okay? The rest will be same, so right up to here. Now, Once you're done, you replay the video yourself. Now left hand side here is cot 1 plus, left hand side here is 1 plus cot square alpha. So write that one down. Okay, then let's do slowly. 1 is 1, so you can just write plus cot alpha is what? In the first chapter, yes, adjacent by opposite, that's right. So here the adjacent is AM, right? So looking at this, AM square, because this is square, divided by opposite is here, this one, PM. So we write here PM square. So this PM square, we multiply, then LCM is PM square, right? And PM square into 1 will be PM square plus this one will remain as it is, AM square. So PM square plus AM square. This PM and AM are the non-hypotenuse sides, so that is the sum of their squares is equal to the square on the hypotenuse by Pythagoras theorem. That's Pythagoras theorem, which says that the square on the hypotenuse of a right triangle, so Pythagoras theorem is applicable only for right triangles. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So this is PM square plus AM square, which is equal to AP square again. And you can change slightly, PM square plus PM square or PM square plus AM square is same. So you can just write here to adjust exactly like this if you want. Otherwise it's same actually. AP square by Pythagoras theorem. So we get there AP square by AM square, right? AP square. Hypotenuse by adjacent again. So hypotenuse by PM. Now this time it's not AM, this is PM. So we have to change this one. PM square plus AM square to the AP square by PM square. Now here, AP is what? Look on the diagram. AP is hypotenuse and PM is opposite. What is the name of this ratio in the first chapter? Yes, that's right, cosec. So hypotenuse by opposite is cosec, so we write cosec alpha, because there is square there, we write your square, which is exactly same as this. So which right hand side, so that will be equal to right hand side. We have shown geometrically that left hand side and right hand side are equal. So our identity is proved, right? The next subheading 2. We have to prove root over, suppose it comes like this, root over, okay, cosec alpha minus 1, cosec alpha minus 1 into 1 plus cosec alpha root over everything equal to cot alpha. Slightly different, but it's not hard, okay, alpha. So alpha, so nothing needs to be changed. Up to here you write same again, okay, pause the video and write. After you're done, you replay the video and join, okay. So here now, let's take out the left hand side, number 2. So right here, number 2, and then do the same thing. Then left hand side is equal to root over cosec alpha minus 1. Okay, cosec alpha minus 1. Cosec alpha minus 1. Sorry, so cosec alpha minus 1 into here 1 plus cosec alpha is what is given to us with a root over it. Now here, if you were to look carefully, then you'll see here it's an identity. So that one we're not doing by any method, from general formula, so you can do that if you want. And then you can bring this one here, plus cosec alpha. No sign is also plus, right? No sign here is plus. We arrange like this so it look like what? A minus B into A plus B, so that we can apply the formula A square. Okay, A square means cosec square alpha minus 1 square. We know that A plus B into A minus B equal to A square minus B squared, a very famous identity. This is not related to trigonometry like that directly, so we can use it. So other than the geometric method, then the rest should be geometric. So cosec is what? In your first chapter, yes, hypotenuse by opposite. So hypotenuse here is AP, so you write AP square by here AP square by opposite is PM, so we write here PM, and not forget to put square because there is square, means it belongs to both now. Root should cover everything, minus 1 square is 1. So next root over AP square minus PM square into 1 will be PM square, okay, divided by here LCM PM square, okay. Now look at this one. This time we're getting a different one, AP square minus PM square. That is also Pythagoras theorem. Look here, AP square, same as this, minus PM, so shift this one from right side to left, and minus PM square will be equal to this one not shifted. So this is also derived out of the Pythagoras theorem. So this is the same one, AP square minus PM square. So that will be equal to, according to Pythagoras theorem, AP square minus PM square equal to AM square. So we can replace it by AM square, as you can see here. AP square minus PM square equal to AM square. We derive it from the main equation. This is the main Pythagoras equation, so that is correct, by PM square. Don't forget to write here, since we know AP square minus PM square is equal to AM square by Pythagoras theorem, by Pythagoras theorem. Write that down, okay? So by using Pythagoras theorem, we have converted this portion to this, but the root is still there, right? Now, as you continue doing it, maybe you can wrap this portion and continue. So that will be equal to root over AM square will come out as single AM, PM square will come out as single PM. And that's it. Now what is AM by PM in the diagram? AM is adjacent, PM is opposite. What is the name of this ratio? Adjacent by opposite, from the first chapter. Adjacent by opposite, yes, that's correct. Adjacent by opposite is cot, right? Adjacent by opposite is cot. So we write here cot, and the angle we are involving here is alpha. So we write here alpha, which is exactly equal to this. So equal to right hand side. So we have proved all this by geometric method. These are important. It comes in exam, okay? For 2 or 3 marks it can come. Okay, we'll cover the next parts, the 17 identities and one small portion in the next video. Okay.